So problem number 11 on the review is exam 1 material. And it's that absolute versus relative change. Okay? And so when we talk about that percent decrease and we want to explain why the answer is not 4%, well, that absolute decrease is totally 4% because we're going from 64% all the way down to 60. So yes, we had an absolute decrease of 4%, but it asks us for the percent decrease. So essentially, what changed from 64 to 60? So the idea is that this gives us the part of the whole that decreased. Essentially, in better terms, or not as mathy terms, is that when you find the absolute decrease, that's assuming the basic rules of everything's out of 100. This percentage decrease goes, okay, what's the percentage decrease of going from 64 to 60 when this is your whole? So we're ignoring the other amount to get to 100. We're just focusing on what change happened within these numbers. So then that's more of the relative change. So you would start with your absolute decrease. And then instead of doing it out of 100, you're limited to your whole is that 64% that graduation rate was at. So then you're going to make sure that this is out of 64. Because this is your highest number. So then that would give us our 4% out of the 64%. Which then turns into, as a decimal, I was like, 625. Hey, look at you. Okay. And then once we have that, I can multiply this by 100 because it's asking for the percentage. So please make sure you read your test questions carefully. If it asks for a percentage, make sure you take the decimal and multiply it. And so then that would just be 6.25% decrease. Mm-hmm. Yeah, it's something. It also helps because in the news and in journalism and such, especially during elections, this is what gets reported. So like when they talk about approval rates and everything, and they'll talk about, oh, well, you know, so-and-so's approval rating has never been higher, or so-and-so's approval rating is up to this amount, so-and-so's, you know, this, or, you know, they're only getting 38% of the vote. Well, you have to look at how much of the vote has been turned in during that time and really sort of go from there. So that's why looking at the percentage increase or decrease is a better way to talk about it. Because even though this example shows that it dropped 4%, it's more impactful of the fact that it's a 6.25% percentage decrease. That indicates much more of a trouble in the situation than just saying, well, it only dropped 4. No, it didn't. So that's why we talk about it.
Okay.
What else would y'all like to see?
Would you be able to go over 9C?
Yeah.
Thank you.
Let me find question 9. So, all right, so we've got, a classroom. So sad. Anybody watch Governor Hogan's presentation today? Yeah. I'm not going back to work until next year. All public schools are closed until the start of the fall. And even then, probably not. So a classroom has, I think, what does it say? Where's my, I gotta make this bigger. 6 freshmen and 8 sophomores. And so, 9C. 9C asks, how many ways can we choose 5 students? What is the probability that they're all sophomores? Okay, well, this isn't too terrible. So the idea is that if we want to look at the probability of just the sophomores, we have to first look at how many ways can we choose 5 students out of the entire class. Okay, because when we're talking about probability, then that's a little different than when we're just trying to figure out how many people we can choose, because we need a whole and then we have to figure out the part of that whole that we're looking at. So, first, after I do that, the next question is, does order matter? No, because all I want to make sure is that out of the 5 students, I want to know what's the chance of getting all the sophomores. So I'm going to use combinations. Okay. So then in order to do that, I've got 8 plus 6 of my classes, or students in my class, so I'm going to have a total of 14 total students. And I'm still on part 1, so I haven't even done anything else yet. So to figure out how many ways I can choose 5, I'm going to have 14 choose 5. So then I'm going to have 14 over okay. Plugging in from our formula. So I'm going to leave this as 14 factorial, and then this is going to become 9 factorial, 5 factorial. And everybody knows about the exclamation, right? We know that doesn't mean like 14! I wish it did, but it doesn't. It means we got to multiply everything out, because we love doing that. That's what we love doing. So then, you can do this in your calculator. You can write it all out. You would get 14. Goodness gracious. So this would simplify down, because everything after that times 10 up in the numerator would cancel with your 9 factorial down in the denominator. If you're confused about that, I can write it out, but it would take up a lot of space. And then once you multiply all of that, you get a really glorious number of just 2002. Okay? So that's the total ways to choose 5. So now, step 2 is how many ways can you choose 5 sophomores? Okay? So we're still going to do the same idea. Does the order matter of the 8 sophomores that I have, of what I want to choose? No. So since order doesn't matter, I'm going to have 8 choose 5. Because the 5 factorial will cancel out here because it's the greater number. And then this will just gloriously simplify down to 56 to pick 5 sophomores. So now that we've done both of those steps, am I good to change the screen?
Yeah.
Okay. So then now step 3, I can find that probability because it's going to be the number of ways I can choose a sophomore out of the total number of choosing 5. So this just becomes 56 out of 2002, which is going to be, I believe, a tiny number. Where's my calculator? Yep. So about 2.8% chance. We've done problems similar to this. This is very similar to like the lottery ball question that we did during class. It was also one of the very last questions we started talking about before we moved on to social distancing. It was the one where I kept saying the phrase balls over and over again, if that helps jog your memory, like a teenage boy, so it's fine. So it's the same idea. If you were looking for extra practice, that would be a good example to look back to. But yeah, that's how you do it. And you don't have to make it this drawn out. You could easily just skip to, okay, well, I know I need to figure out how to choose, 5 out of the 8, and then I need to find the total here. So you can absolutely do that. I just wanted to take the time to break it down and show you sort of the thought process that goes behind all of it. And some of it you actually have to solve ahead of time. So really, we did 9A as part of this in and of itself, because finding the total ways when order doesn't matter is what 9A is literally asking you. So you got an extra problem solved, thrown in there.
Thank you.
We have a little bit of time left. What else? Ask me whatever you would like.
When will the answers be posted?
I was going to post them literally right after we finished class tonight. I just wanted to have a chance for you all to practice stuff first, so that we just didn't, pull up the answer key and be like, yes, I knew it, or, oh, okay.
Okay.
So, yeah. And it's all on there, written out in far more detail than probably you would ever want to read. But it is there. Are we good on questions?
I have a question about the final.
Yes.
So if we have to fill out a truth table, will we have to, like, insert, like, a table?
No. So the only thing you would be doing is just selecting a T or an F. That would be the only thing you would have to do. Mm-hmm.
Okay.
Or I could give you the entire statement, and then I would ask, like, you know, is this true or false? If it was like an actual sentence instead of symbols.
Okay.
Yeah. Is everybody good with medical probability? We're all great with the false positives and the false negatives? Okay.
It's just you gotta talk yourself through it.
Yeah. Those false negatives, false positives, you gotta just be careful on. So, you know, false positive is people who don't have it, but they test positive. And then a false negative is people who have it, and it says they don't. Which is a big debate right now about all of the COVID testing is, like, you know, people who have had it are still testing again, and so it's showing up as, if you have antibodies to it, your test can still show it's positive, and because it's an RNA sequence determiner instead of an actual antibody determiner, it has a very, looking at the data, because I was actually curious and ran it, it's got a very interesting false positive, false negative rate. Not that any of you really care, but, you know. What?
I do have a question about that.
For the...
a clarifying question.
Yeah.
So, how do we know, again, like, which total to use?
So, the total... Alright, so if we're going to look at... Let's just look at number 6. So we got a false positive of 4% and a false negative of 8%. And so then I give 94 out of 1,000 Americans have diabetes. Okay? And then we want to figure out probabilities for everything else. So if I'm putting my table together, I'm going to have my has, does not, and my total running along here. And then I'm going to have tested positive, tested negative, and then my total here. So from the problem that it gave us, since it tells us, well, okay, it says out of 1,000, so I know I want my total table to be out of 1,000. And then 94 Americans out of 1,000 have diabetes, so then the total number that have to have diabetes is 94. So then once I have that, I can just figure out, okay, well, if I have 1,000 people that I tested, 94 tested positive, that means 906 don't have it. Because the goal is you want this last column and this entire row to give you 1,000. So if you add up the total for tested positive, the total that tested negative, and you get something that's not 1,000, you made a boo-boo somewhere. So that would be the easiest place to start with the testing, is to get these rates in. Once you have these totals that I have in red, then you can move to the false negative and the false positive rates and go from there to figure out the other values. So if you were doing that, and I'm going to do this in green here. So let's say, since this is false positive, and we know that 94 people tested positive, and this is our false negative, what we want to make sure is that if we have a false negative, that means that it's people who have diabetes but tested negative. So this here would be 94 times that 0.08. Okay? Because this is your If it's a false negative, they have it, but it's tested negative. Conversely, your false positive is somebody that does not have it, but tests positive. So then this would be your 906 times 0.04. Which then this would be equal to 36.24, and this would be equal to 7.52. And then now that you know these, you know that this entire top row has to add up together to be 94. So you can just take 94, subtract 7.52 from it, and you're going to be left with 86.48. And then you can do the same thing for the second row. So you'd have 906 minus your 36.24. So you would get 869.76. And then you would just add up both of these columns to get your total that tested positive and your total that tested negative. And then use that to answer questions A and B. So this is like 122, 172. Point 28.
Whoa.
What?
Why are there decimals? I thought there are no half people.
Because this is just the accurate total to try to get to 1,000. Because if you rounded, you're not going to make it to 1,000. Because we're talking about probability, we're okay to have the decimals here.
What? I rounded and I got 1,000.
Did you? 122
Yeah.
and 877?
I got 1.
Or did you do 123? Okay.
Yeah.
All right.
But on the test, should we just do decimal places?
Yeah.
Okay.
It should be. The test is designed to be very user-friendly, so you should have a decent time with it. Like, I helped with wording on them, so that way it was very clear, because one of the things that I felt was unfair was that some of it would never tell you, and so people were putting like 8 decimals, some were putting 4, some were putting 2, and some of you were losing credit on questions. That's why if you noticed it, what the computer scored you as and what you got, some of you got a much higher grade because you actually got it right. It just didn't like the formatting of what you typed in. So that's why I regrade all of them. But we have about 10 minutes left, so if anybody has any last questions, otherwise I will post the completely optional, it is not a mandatory class time, just for you to pop in with your last minute questions on Monday, and then that way you take the final on Wednesday and then you're done. Your final grades will be posted by Friday, so you'll know what you got on your final exam, and then that's it.
I have a quick question about probability.
Sure.
So, when you use a fraction
Mm-hmm.
as the answer, when do you use, like, the percent?
So for probability, you can leave it as a fraction. Pretty much anytime. I would suggest doing it as a decimal on the final, just because it's a little finicky with accepting fractions unless you're in a text bar and you can use the equation editor feature. Otherwise, it's just not going to like you. But on it, if it says what is the percentage, so if it asks directly for a percentage, you want to make sure that you have it as a percent. If it asks for, so like if you're looking at question 9, C, like if we go back to this guy, too far. So this said, what is the probability? So you could have left it as this, or you could have put it as this. So that both of these, if this was your test question, are coded to be acceptable. So it will accept either this or this.
Okay.
Mm-hmm. The only time it'll be wrong is if it literally asks you for the percentage and you don't put it.
Okay.
So just be careful. That's the only time. Yeah.
Thank you.
Was everybody good with the conversion factors of number 4? Everybody good with the finance formulas for question 1? Unless it just kicked me off. Did I freeze again?
No, you're fine.
Okay.
No.
Whew. All right.
If it gives me the APR
Mm-hmm.
for one of the questions,
Mm-hmm.
and it says that, so like question 1A,
Mm-hmm.
since it says it pays a 6% APR
Mm-hmm.
compounded monthly, would I have to take 6% and divide it by 12?
No. So because the type of finance formula that you're using there, it's already going to do that for you. So if we're looking at 1A, let's see, 1A while you're here. So because we're saving $2,000 in 3 years, they have an account that pays 6% APR compounded monthly. How much do you need to save each month? So this is multiple deposits. So this would be an annuity formula. So because it's an annuity formula, when you're going in and you're doing your equation, it's already done for you at this step.
Okay. But then, like, the question for, like, 1B, would I have to...
So 1B is going to be different. So 1B is an entirely different formula. So that would just be, it's an APR of 15%, so you would just leave it at that 15. It's only if it's going to tell you that it's compounded a certain way that you would talk about dividing it. But you're not going to encounter something that picky on the final.
Okay.
Mm-hmm. Anything else?
Is 4 just about looking at the table and converting, like, feet to meters and stuff like that?
Yeah, so 4 would be converting meters to feet and finding volume and then going from volume to buckets. So 4 is really broken down so you can go step by step instead of having to do all of it in like one.
Okay.
Mm-hmm.